So we are on 1.15, and this is going to be our last book section before we take a little break and do another project. Yes, we skipped 113. I thought it was something not essential. I didn't want to spend a day going over vocab words. And then 1.14 we are going to get to, but I put it at the end of this unit. We're first going to start with linear and exponential change. Again, another pretty lengthy section, but we'll get through it. So many social media companies experience rapid changes in their use as popularity increases or wanes. Understanding the changes, both positive and negative, can help companies estimate future growth or decline. For each part of the problem, organize the sequence of numbers into a table by pairing the term with the term number. Treat the first number in the sequence as the 0th term, since it's the initial quantity before any change occurs. So this is kind of like your y-intercept. Determine if the sequence is arithmetic, geometric, or neither. If it is arithmetic or geometric, write an expression for the nth term so that we can find, we can predict future values. Write a sentence explaining how the sequence of values is changing within the context given to you. With real data, sequences are rarely perfectly arithmetic or geometric, but it's useful to consider them arithmetic or geometric if you are approximately so. So it doesn't have to always be adding or multiplying by the same exact number every single time. So long as it's pretty close, we can still consider it arithmetic or geometric. So for this first one, suppose Twitter's numbers of tweets in billions per month over a 6-month period beginning in July of a recent year were 8, 8.4, 8.2, or 8.82, 9.26, 7, 9.72, and 10.721. Wow, that was really hard to read those numbers. Okay, so they told us that to treat the first number in the sequence is the 0th term. So our term number, month 0, our initial month when we first started counting, was 8 billion tweets. Month 1, so this would be August, is going to be 8.4 billion. September, October, November, and December listed there. Hopefully that wasn't anything too bad. Now we need to determine whether it's arithmetic, which is adding to the next term. So we're going to add the same number or approximately the same number from one term to one term to get to the next term, and that same number adding throughout. Or it could be geometric, which is multiplying to get to the next term. So what we do to find if it's arithmetic is we're actually going to take the first term minus the 0th term, the second term minus the first term to see what the difference between them is. So I already did the math for you. So the difference between 8 and 8.4 is plus 0.4. And then from 8.4 to 8.82 is plus 0.42. Okay, you can read the rest of the numbers. Apparently I can't speak numbers. They said approximately. Maybe that's approximately, but let's take it one step further. Geometric, we're going to do something similar. Geometric is multiplying to get to the next term, so we're actually going to divide the 0th term, or divide the first term by the 0th term. So 8.4 divided by 8. 8.82 divided by 4. And once we do that, we actually get the same number. We're multiplying the same number each time. So 8 times 1.05 is 8.4. And keep multiplying throughout, and you get the next term. So this sequence is, in fact, geometric. So for geometric, we're going to I don't know if they give you the formula for it later on. I can't remember. Let me see real quick. I'm not seeing them giving you the formula. So it is going to be your first term times your percent change to the nth power. So it's AB to the power x. A is our first term. A is the 8. Our common ratio, the B term, or our rate of change is 1.05 to the n power. And if we're tying this back to the last unit that we just did, this 1.05 is a what? A 5% increase. It's a number greater than 1. We take the decimal, make it into a percent. This is a 5% increase. So we're explaining this. The number of tweets are increasing by about 5% each month. Now, suppose the number of active Google Plus users in millions per month over a 6-month period beginning in July of a recent year were, and there's the numbers, I'm not actually going to read them because apparently I'm terrible at it. So again, we'll start with the 0th month, the initial month, July, August, September, October, November, December. Okay, just like I did before. Now I'm going to figure out, is it arithmetic or is it geometric? So I'm going to write the difference on the left-hand side for arithmetic. And then if it's not the same, then I'll go geometric on the right-hand side, just like we did. So when I take the difference between each number, so 3.68 minus 3.8, I get negative 0.12. So my sequence is going down each month by 0.12. I'm going downward. All of these are the same, so it's an arithmetic sequence. Arithmetic sequence is going to be our first term minus our difference times n. So what this is saying is that the number of active users for Google Plus decreased by 0.12 million or 120,000 users per month. So moving on, here's a good refresh on functions. Independent, known as the input. Dependent, known as the output. What it looks like as a table. Remember, input, independence, what we're plugging in, and then output is dependent. It depends on whatever we're plugging in. So if you work 15 hours a week, we would plug that in, multiply it by, plug it in for n, multiply it by 15.75 because that's your hourly wage, and you'd get $236.25 as your weekly salary. From there, we can graph it, label our axes, scaling, all that good stuff. Modeling, definition is there for you. We'll often model a situation by looking at the changes that we see in a graph or table and finding patterns in those changes. So for example, number 1, suppose the owner of a new company has a goal of hiring 500 new gaining 500 new customers every fiscal quarter. So that's every 3 months out of the year. We want to gain 500 customers. So that's what it would look like. Quarter 0, they have no customers. Every quarter after that, so quarter 1, 2, 3, 4, and then the following year, you'd have quarter 5 and 6, just continually increasing by adding 500. This is what it would look like if we were to graph it. This is what it would look like if we were to write an equation for it. All that fun stuff. Then, just a FYI, there's 4 quarters in a year for businesses, just like we have 4 quarters in a school year at our school. So you can read more about that if you wish. Linear functions, linear growth is an increasing function. Linear decay is when the values are decreasing. Equation of linear functions have the form dependent variable equals the starting value plus the rate of change times the independent variable. Kind of y equals mx plus b, except in this case it's y equals b plus mx. but same kind of deal where your independent variable and your dependent variable are both letters, usually x and y. Your starting values, your y-intercept, your rate of change is typically your slope. Remember, your 0th term is your y-intercept because it's when x equals 0. X equals 0 on the y-intercept. So if you're looking at the x-axis is a number line, the y-axis intercepts the x-axis at 0. Okay? So we have y-intercept. If we're looking at a table, we need to determine if y is a linear function, explain why or why not. So we have the y-intercept when x equals 0, y equals -18. That's my y-intercept. And then we need to figure out if there's a consistent rate of change to be our slope from -18 to -12 plus 6, -12 to -6 plus 6. Plus 6, plus 6, plus 6. So my slope is plus 6. So as y values increase by 6, x values increase by 1. So yes, this is a function. I can write it as y equals -18 plus 6x. Similar to y equals mx plus b when you'd have y equals 6x minus 18. Same thing. If you are if you have an interest-free loan of $800 and you are paying it off at a rate of $50 a month, model the situation with a table, graph, and equation. Is the function a linear function? How many months will it take to repay the loan? So month 0, you have $800. You started initially with $800. That is month 0. Your y-intercept. After the first month, you've paid off $50. Second month, $50. Third month, $50. Fourth month, $50 more dollars. And 5 months, $50 more dollars. Okay? So I scaled my graph x's just by ones, 1, 2, 3, 4, 5. And then my y-axis, I scaled by 200s. Just so I could fit everything in. I plotted my points. Connected them with a line, and then I labeled my axes. Month was what was represented as x. Amount left to pay is represented as y. So then I need to make my equation. We'll use the variables a as the amount left to pay and m as months because those are my two variables that were given in the table. So A equals my initial amount. A equals 800 minus 50, which is my rate of change, times M. So I'm plugging in months and getting out the amount left to pay. If I were to solve this for M, I would get 16 months to repay my loan in full. A couple more examples you can look through. They might help you for the summative, so give them a quick look through. Here was the equation that I was looking for before. For geometric sequences, you have your starting variable times your multiplier to the nth power. A little bit different than you learned in Math 1 when you were talking about geometric and arithmetic sequences. Or the growth, exponential growth in regards to like population increase. Little bit different in this case. This formula is a lot easier in my opinion. So we have exponential growth, exponential decay. Notice that its exponential growth starts out slow and it increases quickly. Exponential decay decreases quickly and then kind of evens off towards the end. So number 4, we just have 2 left. Number 4, a company wants to project growth using both linear and exponential change to see the long-term effects. The company begins with 150 clients. That's important to know. The CEO wants to project growth assuming 15 new clients per month versus a 10% growth in clients each month. So we're modeling each situation with a function, either 15 new customers per month or a 10% growth. How many months will it take for the companies to reach 500 clients with each approach? So with the first approach, we're going to be using arithmetic because we are adding 15 new clients each year. So we start with, so the number of clients that we have equals the initial amount of clients, which is 150, plus 15 clients each month. And N is going to represent the number of months in this case. Why did I choose N? I don't really know. I could have chosen X. I could have chosen M. I don't know why I chose N. Then we want to know when they're going to reach 500 clients. So I'm going to plug in 500 for the number of clients and then solve for N because I want to know how many months it's going to take. And N was the number of months. So I'm solving for N, and I get 23 and a half months. Now with the second approach, 10% growth in clients each month will be a geometric, as my rate of change is 1.10. So 10% is written as 0.1 or 0.10 as a decimal. And then remember back to the last section that we did, 1.10 is how we represent that as an increase in 10%. Okay, so then again, I'm going to plug in 500 for the number of clients and solve for N. My son wants Play-Doh right now. I'm going to graph this on Desmos to solve, and X will equal around 12.63, so I just rounded to 13 months. So for this one, 10% growth will get more customers quicker. It'll get 500 customers in 13 months versus the arithmetic approach of 15 new customers a month at 23 and a half months. And then for question number 5, last one, city planners for a city with a current population of 100,000 residents are modeling the population in various ways to help them make decisions related to resources. Experts disagree on the growth rate and model since they're using different data. But they do know they have resources for only 200,000 clients. For each scenario, write a function and use it to determine when the city will be at its maximum capacity. So maximum capacity is at 200,000. So our starting population is 100,000. And I believe my answer key might be wrong on this one as I'm looking at it right now. So we'll have population. So I need to write this in. Population equals 100,000 plus 5,000 new residents each year. And N, if I solved for N, population will be 200,000 equals 100,000 plus 5,000 N. So it should be in about 20 years. Okay, then population increases by 8,500 residents per year. So again, I will have population equals 10,000 plus 8,500 times N. Same thing, I'm going to plug 200,000 in for N. N will equal 12 years. 2.5%, we have population equals 100,000. Oh, this should be 100,000 as well. Times 1.025 to the nth power. So N will equal 29 years. And I used Desmos to solve that one. And then the last one is population by 3%, so we have 100,000 times 1.03 to the nth power, so n should equal 24 years.